Hello, everybody. Um, Welcome to week 5 of CPCS 203, Programming 2. So today I'm going to talk about, I hope to get to 4 different topics, really small topics, nothing, no major new concepts, but things that I hope will clarify some of the things, some of the concepts we have already learned. So let me begin with something elementary. Um, so I made a new project for today called week 5 underscore 1. Um, and this is a blank project right now. And I guess you already understand, delete this, you already understand most of the things that we have in here. We have a public class. Uh, we have a public method called main, as always, which doesn't return anything. So the return type of the main method is void. But between the public and the void keywords, we have this keyword, static. And we haven't really talked about what that does. Um, so I'm so we're going to get to this in a little more detail, uh, not today, but on another day. But for the moment, what you have to understand is that uh, if you can you can if you you can declare classes static, you can declare their methods static, as is being done at this point. You can even declare some variables, member variables of classes. You can make those static. Now, uh, I'm only going to tell you right now what happens when you declare a method, like the main method over here. What happens when you declare a member method of a class static? Uh, you've seen so far that when you want to use any method, you first have to create an object of that class, right? But notice that we always run the main method. That's kind of where the execution of our program begins or starts. We never really create an object of the class, the test class that contains the main method. And the reason that is so is when you declare a member method, like this main method, of a class, like this class week 5 underscore 1, when you declare a method of a class static, that makes it so that in order to run or execute that method, you do not first need to create an object of its class. And this is not the only situation in which we have seen that happen. You are already using, or you have already used, a method a number of times. Uh, a method whose for whose class you did not create an object first. Think about it for a few seconds and see if you can remind yourself what that method was. Pause it, pause the video if you want for a few seconds. The answer is, I'm just going to type it up here. Remember this? Math.random, the random method that we've been using to, to produce random numbers. We never create an object of the math class. And we never did that. And the reason was we didn't have to, because the random method that we used was a static method, which meant it was not necessary to create an object of the math class first. So that's what I wanted to tell you about static methods. That was one thing. So I hope that uh, reduces the number of mysteries in any codes that you've been writing so far. So that was one thing. So basically, why do we declare main method static? That what that does for us? Okay, so now let us move on to the second thing that we're going to talk about, and it is uh, how Java initializes different variables. Now, you've already seen um, that. So, although I have mentioned that here and there at different places, just want to consolidate these ideas. Um, I said that I already said that when you create an object of a class, Java will initialize all of that object's member variables to all numeric variables to 0, all string variables, string members to null strings, meaning empty strings, um, all characters to null characters, and so on. But we've also seen that in some places, um, like when we were creating counter variables for loops, it turned out that we had to initialize those variables before using them, because if we didn't, they, we would get a compiler error. So today, I'm going to do a simple, small exercise that demonstrates that difference. So what I'm going to do is I am going to begin by creating a very simple class. Let me call this one student. I'm going to add that to this project. And so in the student class, it's going to be so simple actually. This class is not even going to have any member methods. It's going to be a class that just contains a bunch of member variables. Okay. Um, so let's say we have a string member variable called name. We have another one that a numeric one contains age. Another one that is of type Boolean. And let's say this one has information about whether the student is a science student and a character variable that stores the gender of the student. Okay, 4 variables. Now, there's another thing. I want you to get into the habit of anytime you declare member variables, member methods of a class, uh, I don't just want you to leave uh, their visibility to the default level. I really want you to think about what you want that visibility to be. So remember, so far we are familiar with 3 visibility levels: public, private, and default. Remember, if we don't write anything, visibility level is default. So you could keep that for the moment, because we are not going to write any methods, any accessor methods that allow us to read and write um, to these variables. So I'm just going to make all of these guys public, just so we could have also let them be default. I could have still accessed these variables from the outside, but I'm just going to make them public just to get into the habit of thinking and about visibility levels. And so this is our class. That's all. That's all that's going to be to it. And let's go back to the main method. And what I'm going to do is I am going to create a student object. Let's call this one S1. Call to the default constructor of student. So now object S1, capital S, object S1 is of type is a student object. And what I want to see is, so if I create a student object without any manual assignment of values to of its member variables, let's see what the Java compiler initializes them to. Um, so we had 4 member variables. We have a name. Just write it like this: student.name, and I'm going to print out s1.name. Actually, let me just s1.name, and we had age. Let's go to s1.age. We had this Boolean variable is science major, Maybe also get into the habit of using this autocomplete feature that the IDE gives you. So S1 dot, the last one was gender. S1 dot C, gender. There you go. So this is going to print out the values that these 4 member variables of S1 object have by default. Okay, and let's actually see if they actually initialize to anything, and there you go. So s1.name is initialized, is a string, and is initialized by default to a null string. The age variable is an integer, the numeric variable, and is initialized to a 0 by default. The is science major member variable is a Boolean and is initialized by default to false, or think of it as a 0. And the S1, the gender variable is a character. The character variable is initialized to a null character, and it's not printing out as anything. Okay, so this is, you can see that this was the initialization, default initialization of member variables of the class by the Java compiler. So now in the main method, let's create some other variables. Let's create simple integer x, maybe string y. Do this one by one, and I'm not going to assign any values. I'm not going to assign any value to x. X in main method, and just want to print out the value of x. So let me try to run this. And as expected, we get a compiler error. And the reason is that x has not been initialized. The Java compiler does not initialize x to any value because it is not a member variable of any class. This is a variable created inside a method of some class. The scope or the visibility, for this reason, the visibility of this variable, or I should say this variable exists only inside this method main. Okay. And for this reason, because this is not a member variable of a class, it is not initialized by the Java compiler. Now, just to show you that I did not make any other mistake, let me initialize initialize x to 0 manually myself, and run this code again with a slight change. And there you go. It works. And want to check same thing for another type of variable. So let's say we have the string y. Going to print out its value again. Let me first try it without initializing y, string y. I get, as expected, a compiler error. Let me go back in and initialize the string to something more fun, initialized string. Okay, run it again, and y in main method initialize string. There you go. This works. So any variable that you declare and create inside a method, like this main method over here, you have to initialize that variable before using it. Okay. If you don't, you get a compiler error. So hopefully this should also help you out with debugging your own code. Okay. Okay, so let me move on to the third topic I want to touch on today. This is the differences between variables of primitive data types and object types. So primitive data types are all the data types that are inbuilt into Java. So you've been using them. We used 4 of them today. So characters, integers, all the numeric variable data types. So all those are examples of primitive data types. Primitive is another word that just means simple. Okay. And we've also seen that we can also create variables or in the form of that are basically objects of different classes. So I'm going to show you some simple stuff first, that some code that will work as you expect it for primitive member variables, primitive variables, and then we'll try out the same thing for objects, and we'll see different behavior. And so I'm going to try to understand how why the two types of code work so different. The two codes work so differently. Okay, so I'm going to create for the primitive data type. I'm just going to do this for integers. Okay, let me create an integer I. Let me initialize that to 1. I think I think you can find the same example in the slides. Another integer j, and I'm initializing its value to 2. And system.out.println, and I'm going to print these out as well, so we can follow along and see and to keep this stuff nicely formatted. Empty line. And then I'm going to do something over here. I'm going to make an assignment. So I'm going to say I is equal to j. All right. So I'm initializing I to 1. I'm initializing j to 2. I won't be needing this one for the moment. Just going to comment out all the other stuff I still have over here. There you go. So we're just looking at I and j, just these two variables. So I is initialized to 1, j to 2, I'm printing them out, then I'm making an assignment. I is equal to j, and then I'm printing out I and j again. And the question is, what will be the values of I and j before this assignment and after the assignment? Before is easy, the value of I is expected to be 1, the value of j is expected to be 2. You should see that over here. Then when we say I is equal to j, and print out both values again, i's value will be 2 and j's value should also be 2. Let me run this. There you go, as expected. Nothing special over here. And I'm going to do something else over here. After I do this, I set the value of I equal to 3, and I print out the values of I and j again. So over here, values of I and j are expected to be 2 and 2. Over here, we expected them to be 1 and 2. And when we print out I and j for a third time, we expect I, after this line executes, we expect the value of I to be 3, because we assign it that value, and the value of j will still be 2. There you go. 1, 2, 2, 2, 3, 2. 1, 2, 2, 2, 3, 2. That's as we expected. So I and j are two separate variables. No rocket science over here. Okay, let's basically do the same thing for class, for objects. Okay, so let me uncomment what I just commented. We have student object S1 from before. Let me do something more interesting. Let me assign it some values other than default values. S1 age, let's say Omar name's age is 20. S1 is science major. Let's say the guy is a science major, and S1 dot gender, and obviously from the name, the guy is male. Okay. And to keep things neat, actually I don't need that anymore. Okay, so now I have student object S1. I initialize its name to Omar name, age 20, is science major, true, gender M or male. Okay, and I'm printing these out as well. And actually, before I do that, let me clean this up, and let me also create another student object S2, and I guess for simplicity's sake, let me leave this uninitialized, so basically all values will be 0, and let me also print out all of these values. So the second object is student S2. I'm going to print out all these values. Okay. So I guess if we execute this, and we run these lines. S1 will show up as Umar name 20 true male, and student S2 will show up as null string age 0 is science major false, gender null, nothing, no character. There you go. Class example for S1 Umar name age 20 true M, and the other guy, other record shows up as no name 0 false, nothing. So just like I did for primitive variables I, primitive integer variables I and j, let me do this assignment. I is equal to j. Let me do the same thing for the student objects. S1 is equal to S2. And the next question is, when I print out all of these fields for S1 and S2, what am I expected to see? What do you expect to see? Well, we're assigning S2 to S1. First of all, we can do that for objects. Okay, so this is, should not throw up an error. Assigning S2 to S1, which means we expect these values for S2, which were null string, age 0, false, gender nothing. We expect those values to be assigned to all those member variables of S1. So let's see if that is the case. Go. So initially, first the output from the beginning was this. Then after we make the assignment, S1 name null, age 0, the science major false, gender nothing. Same as S2. So this is not surprising. Let's now do the second assignment. All right. So let me go in here and let me, too much, okay. Let me assign some new values to the member variables of S1. Okay. So let's say the student record I put in now is mix things up. Science major false, gender F. So complete new data. Data that we did not have in here before. So I assign all these new values to S1. And then I'm going to print out everything that's in object S1 and S2. I'm going to print those out again. My question is, what will we see? What should we see? Well, obviously, S1's name, age, science major should now change to name Rabia Umar, age 22, science major false, gender F. And S2, remember up here, S2 was null string, age 0, science major false, gender F actually. So I guess that's what we expect to see for the values of S2. Okay, let me run this again. Let's look at the output. Whoa. Let's go step by step. So the initial values, Umar name 20, S2 object are the default initializations of all member variables. Then we make the assignment, S1 is equal to S2, and after that everything became null, 0, false, null. And then when we make this new assignment to members of S1, S1 appears as expected. Rabia Umar, age 22, science major false, gender F. But look at what happens to S2. I didn't. Did, when did we do that? When did we assign the same data values to S2? We didn't do that. So how come they show up, the same values that we have for S1 show up for the member variables of S2? Here's what's happening. Here's the explanation. This is what happens when we work with primitive data types, like the integer I and j. This is what we were doing. Before I and j were, before we did I equal to j, I and j were two different variables, and even after we say I is equal to j, I and j in your computer's memory are two separate variables. They take up their own space. Okay? This is not how it works for object variables. This is how it is before. So remember, we did S1 is equal to S2. So in this slide, this is a different example. We have two objects. One is of type of class circle, the other one also of class circle. They have only one member variable called radius. The first object C1 exists in one place in memory. Oh, sorry. The other object C2 exists someplace else in memory. So we have two different objects before. But when you say one object is equal to another object, so like C1 is equal to C2, like we did, S1 is equal to S2, the values of member variables are not copied from one object into another. That is not what happens. Instead, this is what happens. Remember, when you declare an object, you're only creating an address. You're only creating basically, yeah, a pointer to some place in memory. When you say C1 is equal to C2, what you're saying is for in the case of objects, what happens is the reference to object C1 that used to point to this place in memory, that now becomes a reference to this other object, C2. So basically the references C1 and C2 both now point to the same place in memory, to the same object that is C2. This object C1, you have lost access to it. And what Java does for that, once you have lost references, once you have no reference to a certain object in your program, you cannot get back to it. After this line of code executes, you cannot get back to this object over here. What Java does is it performs something called garbage collection, and it will deallocate that memory. It will take that memory back, and the object is basically, for all practical purposes, it's gone. It's been thrown out of memory. And now you have two references, C1 and C2, which both are basically two names, two references to the same place, the same circle object in memory. And this is what is happening with our student object. When we said S1 is equal to S2, we basically threw away the object, the reference to this first object that we had in memory. S1 and S2, after this line, both point to the same object S2. And when we make changes over here to any one of the objects, S1 or S2, either one, those changes are happening to that same one object. So after that, since S1 and S2 both point to the same place in memory, whether you access a member variable by S1.name or S2.name, you're accessing the same member variable of the same object. So This is a very important thing you have to know when you're working with objects in your program. Make sure you understand this because you will definitely need this understanding for the programming task we will do in class, um, in next class. Okay. There's also, should add this, this is there's some information about garbage collection and how it works in Java in your slides. Yeah, so I guess that's it for today. We'll talk about the date class in in the Java util library. We'll talk about an API. We'll talk about that next time. All right. See you all tomorrow.